So hello everyone. So today we are going to solve removing digits from CSCS problem set. So let's have a read. You are given the integer n. On each step, you must subtract one of the digits from the number. How many steps required to make the number equal to zero? Okay. So you have the number, right? Suppose let's take the case 27, right? You have to how many steps required to make the number equal to zero? So we have to make this number equal to zero. And what we can do, we can take the n one of the digits from this number, that is, we can take 2 or we can take 7, and we subtract it from the number. That is, the resultant would be 27 minus 25, and the resultant would be here 20, right? Now, again, you have two options that you can subtract 2 and you can subtract 5. You can subtract here 2, right? Because there is no point to subtract 0. The number is going to be itself, right? So we have two possibilities here that we can subtract 2. If we subtract 2, then the resultant would be 23, and here the resultant would be 23. Now you can see that you have to solve 20 here and 20 here. So these are the sub problems that you are going to solve, sub problems. So to if there are sub problems, so we have to use dynamic programming, right? Dynamic programming. Now, how what's the intuition to solve this problem, right? We have to define the transitions. We have to define the base case, right? So what could be the base case? What could be the transitions we can do, right? Let's try to solve it, right? So you have the number 27, right? So what could you do? You have the number of options is 2, right? And if the digit is going to be something like that, then again you have the number of options is the number of digits that you have, right? Now here you could do two things, that you can subtract 2 or you can subtract 27, right? So the resultant is going to be here 25. The resultant here is going to be 20, 20, right? Let's try to solve it further, right? Now here again you have 23. Now here again you have to again you have to subtract 5, then the resultant is going to be 20. If you are going to solve 23, the resultant would be subtracting first 2, the answer is 21, and from the subtract 3, that is going to be 20. So let's we have the 20, 20, 20. So let's solve for the 20. So we have the 18, and we are not going to call it, because if the digit is 0, we are not going to call it. Now for 18, there is two possible things that you can do. That is, you can subtract 1, it is going to be 17, it is going to be 10. So for 10, it is going to be 9, we do not call on the right side, right? Digit, because the digit is 0. So from 9, you can subtract 9, the answer is 0. So how many steps you can do? One is this, where 1, and one is this, one is this, one is this. So 1, 2, 3, 4, 5. So in 5 steps, you can turn it to 0, right? You can turn it to 0. So at every transition, you add 1, right? At every transition, you have to add 1. Okay. So ultimately, you reach at the 0. So the base case would be 0, right? The base case would be 0. And how we are going to do the transition, right? How we are going to do the transition. Now you have the base case that dp of 0 equals to 0. That you are going to make dp of I. What dp of I represents what is the number of number what are the number of steps required to make the number I to 0. dp of I represents this, the number of steps required to make I to 0 by doing by subtracting one of the digit from that number, right? So the number of steps required to turn 0 to 0 is going to be 0. That you are not going to do any of you are not going to do the operation, right? Now you have to fill the dp. So by using this base case, and what would be the transition? What would be the transition? Transition is going to be dp of I equals to dp of I minus digit plus 1. That you are going to subtract the digit, and by doing this operation, you have to add 1. That you are going to do the operation, right? But when you have to do, if the digit is not equal to 0, if digit is not equal to 0, right? So let's try to fill our dp table by using these two things. So initially we will fill with it with a very large number that we have to find the minimum steps, right? Minimum steps. So we are going to fill it with infinity, right? And the base case would be 0. The base case would be 0 for 0, right? Right. Now for all the single digits, the number of ways is going to be 1. The number of ways is going to be 1, right? You have to subtract 1. You have to subtract 1 from 1. You have to subtract 2 from 2. So you have, if the single digit number, if the number is single digit, then you have to subtract that digit, right? Sub. So the answer for this is going to be 1. So for all these, the answer is going to be 1, right? Now for 10, what transition you have to do? You have to traverse for all the digits, right? You have to traverse for all the digits. For suppose this is the I, this is the I we have to traverse for I equals to 1, I less than equal to n, I plus plus. So we filled this to 1, right? Now for if the I is equals to 10, the current I equals to 10, right? So you have to traverse for all the digits the string that you have. So what we can, how we fetch the string? We fetch the string that char minus 0, right? We have the character 1 minus 0, that is the character. So we travel for all the string, all the digits, right? We traverse for all the digits for I equals to 10. First digit is going to be 1, second digit is going to be 0, and we have to apply the condition that if digit is not equal to 0. So the digit is going to be 1. So next you are going to take what? You are going to take subtract 9. Now you have to solve for 9, you already solved. So for 10 the answer is going to be 2. Why? Because you subtract 1 and you have to add plus 1 here, right? You do the one step to make 9, right? So that's the transition that you have to do. So let's quickly fill for all of this, right? So for 11 you have again two. For 11 you have two cases that you can choose one, or you can choose one. In both the cases you are going to make 10. For 10 the answer is 2, so 2 plus 1 is going to be 3. So for all of this the answer is going to be 3 for 11, right? Now for 12, if you subtract the digit 1, if you subtract the digit 1 it is going to be 10, and it is going to be 11, and if you subtract 2 it is going to be 10. So for 11 the answer is 3. For 10 the answer is 12, right? You have to subtract 1. If you have to subtract 1, it is going to be 11, it is going to be 10. For 10 the answer is 2, 2 plus 1 is 3, and for 11 the answer is 3, 3 plus 1 is 4. What is the minimum? We have to take the minimum. So minimum is going to be 3, right? Similarly for 11 you have to subtract 10, which is the minimum. So for all the up to 19 it is going to be 3, right? Because you are going to make 10 by subtracting the last digit. 17 minus 7, 10, 10 plus the answer for 10 is going to, it's 2, 2 plus 1 is 3, right? Like that. For up to 19 the answer is going to be 3. Now what is the answer for 20? For 20 you are going to minus 2, that is going to be 18. So for answer that for the 18 answer is 3, so 3 plus 1 is going to be 4. You are not going to consider second case because digit is equal to 0. So for 20 the answer is going to be 4. Now for 21 you can make two transitions that you can subtract 2, that is going to be 18. You can make 20. So 20, 18 the answer is going to be, for 18, for 20 it is going to be 19, right? For 18 the answer is going to be, for 19 the answer is 3, 3 plus 1 is 4, it is going to be 5. So for 24, 21 answer is. Now for 22 you can subtract 20, you can have again 20. So 20 plus 1, it is going to be 5. Now for 23, now for 23 you can subtract 2. So you have 21, you can subtract 3, you have 20. So for 21 the answer is going to be 4 plus 1, 5. For 20 the answer is going to be 4 plus 1, that is going to have, both are the answer are equal, so you're going to fill with 5. So this is how you can fill your DP table, right? So this is the case. So let's try to code it. Let's try to code it. So let's try to code it. So we have the number n, take the input, let's define the dp vector, size n plus 1, initialize it with some big number. Let's define the base case, that is dp of 0 equals to 0, and we have to traverse for all the possible numbers, right? And let's take the number as a string to string I. Now, if for each character in this, for each digit, right, how can we extract the digit for each character? For each character, this is the way that we can extract the digit ch minus 0, right? And we have to do the dp transition dp of I equals to minimum of dp of I, comma dp of I minus digit plus 1, right? If we are going to do the operation, we have to do plus 1 and we have to take the minimum. And finally, we have to return the dp of n, right? So let's try it out. Yes, so the number of steps required to make the 27 to 0 is going to be 5. So let's discuss the time complexity. Time complexity. So first loop is go from n, right? First loop is go from n. So this is going to be big of n. Now the second loop is going to be from the size of the this number that we have, that is if it is the 3-digit number, if it is the 4-digit number, right? It is going to like that. So it can be anything number. So we have let's discuss the first case, that we have the 10 raised to the power 6. For 10 raised to the power 6, we have the 7-digit x max, 7 digits. So it is going to be big of O n into 7 in first case. In worst case, it is going to be big of O n into 7, right? So this is the time complexity. We are using the space of n plus 1 dp vector space. So this is the space complexity. So I hope you got this. Thank you.